This conference will now be recorded.
Yeah, thank you all for joining the demo session. So today we will be seeing a bit on the what all things we will be covering with this DB Performance Engineering course, especially like how our course structure will be, and what all things will be the which will be in our scope, right, in the course. And we will also try to see like what all can be covered and what all is little out of scope, and what is the use, like what is the value which we will carry after this course, and those things we will try to see today. And also from this you will understand like how this course will be useful in your project, especially people who are pursuing performance engineering very much. And it will be a really useful course because nowadays many things which are happening are from the very minute level. Like for example, performance engineering as such, people are expecting in the code profile, like code level and also the database level profiling, but many are not aware, like on the database side it's many are still it's a black box. And many things like it's a fear box for some people, like there will be a lot of SQL language there, and it will be very it might be little tough for us and those things. So we will try to understand those, like is like how complex things are and how it will be useful. Is it too complex that we whether we can learn this or not, or there will be some like lot of coding required knowledge, and those things we will try to understand in today. Okay, so let me share my screen. Let me know if my voice is a little feeble, because if you can interrupt me anytime if you feel like the voice is not clear. I hope now it's clear for all. Yeah, so basically if we see database performance engineering, or better than saying it engineering, I can call it database performance tuning. Okay, because here we are more looking into the optimization, right? So how well you can optimize many things. Like for example, how well can you optimize the architecture, like if you have a Oracle DB, so how the architecture can be well tuned, optimized, so that your resources are being used properly. Okay, so how do you do that? The techniques for that, the tools for that, and some hints, or we can say some tips and tricks to do that, those things. Okay, so that will be covered. And also the second thing is, one is architecture, the second is the query itself, right? Because whenever we speak about database, there are two things, or the two major we can say pillars to the tuning. One is the architecture, the database itself, the DBMS whichever we use, and the second is the query, right? Whichever query we write, and how do we tune it, like the process, the procedures, and the tips and tricks for that, like how you tune those queries. And when this query comes into picture, like many have this doubt, or we can say a query, that do we need to know SQL very well? So I will say it's not that you need to have a very big command over SQL, but what we expect is a basic knowledge. Like for example, you need to know a little bit of select statement, insert statements, little bit of and, or, and all. Then you need to know a little bit of what is a how to fetch a data from a table. Simple. Okay, so if you know the such basics, a simple basics of SQL, that's more than enough. Because here we are not developing anything as such, but here our main goal is to achieve, like to make you capable of providing those recommendations, okay, required to tune your database, or to tune the system which you are using, so that instead of a query, you can run 10 queries with the same resource, right? So those are the value additions which we are looking for, and which doesn't require a very detailed knowledge of SQL now. But yeah, as you progress, as you become experts in database performance engineering or tuning, obviously SQL language will come and go again and again, and you will obviously become experts in that. So that's a later on. So now if we see the course structure, let me go to the website. Am I audible, guys? Everyone?
Yeah, Vishnu, we can hear you. We can hear you.
Okay, okay. Yeah. There is a pin drop silence, so I thought maybe it's a night session. So is it like the excitement is less?
Nothing like that, because you are just sharing the information. We are just
Yeah.
hearing immediately.
Mhm.
Thank you.
Yes. Yeah, 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 yeah. Thanks, Arun. Okay, so obviously you would have gone through all this, but just I will be going through the course structure so that you can ask any queries related to like what will be covered and what not and all. You'll get an idea uh, to evaluate, right? Like what all that, because it's very valuable to understand what your time is being invested in. So it's better to know it now rather than later on, right? Okay, so now, for who is like who can enroll? Obviously, performance engineers are the first choice. We can say who can enroll. Then obviously the other testers also can, and who are going to like pursue into performance tuning and all those careers background. Then test architects especially, because they need to be really good at all the testing practices, especially tuning. So that will help. And also people who are pursuing into a career of full stack QA, right? If this word is becoming more and more popular nowadays, so even those, for those also this course will help a lot. Now, when we speak about database performance tuning, first of all, as I said, the main thing which we need to tune is the database architecture. Okay, so we will in this course we will be spending a good amount of time to understand the architecture tuning. So especially we will be looking into the Oracle DB, which is a like very common DB and also majorly used DB in most of the applications on the network. So Oracle DB, and little, if time permits, I will also cover a small portion on the SQL DB, SQL DB, so that people can try to compare with both. But that's again only if the time permits, because Oracle DB itself is a huge subject. We will try to cover it in deep, everything. Then we have the database blocks, PG. We will try to understand all those architectural details, okay, in very in depth, what how Oracle DB works, and what are the components of an Oracle DB. Those things we'll be covering in detail. Then Oracle tuning basics, we will try to understand. Like for example, how you tune a bad SQL. What are some execution plans? What is the table partition, SQL statement processing, and all those stuff. What is an AWR report? Okay, and the events analysis. All those we will try to see. And whenever there is something called and analysis, you need to know very well how to pull out the reports, right? So we will have a good time of good chunk of time, especially for that, to understand how do you collect your statistics or reports. So there are different type methods of collecting your reports, like there are VSQL plans here, then there is auto trace, then there is a DVMS plan and all those. So we will be covering those. Like basically this is nothing but you have some statistics, right? And you need to collect those. So how do you do that? So for that we'll be using the SQL developer tool, right? And in that SQL developer, how you pull out these reports to analyze. So those we will be seeing. Okay. So basically to pull out these reports, there are different methods. We will be seeing three important methods of that, which has different applications. Okay, that we will see when we go to that. Then we will understand more on the indexes and access pathways, how they improve the performance. Then hints and joins, we'll try to understand how you optimizer hints will help you to optimize your queries. Okay, how you can improve your query performance by using hints. then optimizer operators, different operators which you use to optimize those queries, and different SQL tuning. Okay, like techniques, like for example, instead of and you instead of or you use and. So how it improves the performance. So those some simple techniques, okay, which is like a handbook you can use to improve the query performance, that we will see. And later on, little bit of advanced concepts we will see, of what is a cursor sharing, and some what are bind variables, some what is this term called dynamic statistics and all, which is a little advanced. We'll not go that deep into that, but we will try to see more like an overview what these are, so that when others speak about this, we need to know, right, like what these are. So that's in a nutshell about in the course, like what we'll be covering in depth. Now, the other thing is, for this course dependency, if we speak about, I will be give I have one demo application, not application, I will call demo DB. Okay, so I will be giving those links to you, so you can install it in your machine, the local machine, and so whenever we do some hands-on, you can use that DB for doing those hands-on. It's a well populated DB, which is ready to use, and many people use that for the database related. Even the DB is use that to for their courses and all. So we'll be using that. For that, we'll need a virtual box machine to be created in your local. So that I'll be sharing. That's a prerequisite, I can say, only, nothing else. Then if knowledge wise is concerned, what I'm looking for is a good like a testing background is a good thing. If you have a good testing background, that's a good thing. And also a little bit, if at least you should have heard about SQL, like what happens, not very deep knowledge, because most of the things we will be covering in this course. With that itself, you will get the idea of SQL and all, like what is it. But if you have a bit of a good knowledge means like at least some basic statements you can write, that's more than enough. So that's a prerequisite which I'm expecting. So anyone, any question from the course structure or course syllabus? Okay, so right. Now let's start with the sessions. Basically, today we will try to see a bit on the, as I said, on the architecture side. So how basically, how do we tune the architecture, and what are some important components inside the Oracle DB? Okay. So now, this question might come into your mind, like what is the necessity, right? SQL tuning, like why is it necessary to tune the SQL? Because we might think, okay, the Oracle DB itself is very capable of giving high performing queries to us, the outputs and all, and the milliseconds, like then could be like queries will take only 2 milliseconds or 5 milliseconds. So why do we need to tune this? So basically, that's a good question. Oracle is a very strong database, because it has evolved with time. Okay, and it's a very old database, so it itself does many things to improve the performance. Okay, but see, always there are some manual things which we can do and improve the performance. Now, for example, now if you have a query which is taking 5 milliseconds or whatever, now if the records, or we can say the volume is increasing, that 5 milliseconds might reach even 1 second or 5 seconds or 10 seconds, as per the amount of volume of data which you are trying to insert and all. So now if that 5 milliseconds you can bring down to, let's say, 1 millisecond. Okay, I will not say time, there's something called cost, okay, in performance engineering of database very specifically. So if you can bring down the cost to, let's say, 20%, okay, like initially it was 10, now you made it 2. Okay, so reducing the cost from 10 to 2 means you are reducing 80% of the resource utilization of the database. So you are obviously reducing the increasing the performance, and the resource utilization you are optimizing. Okay, so how do we do that? There are different techniques, so that's what we will see. And again, it's very easy to use. People, they don't put enough time into this, that's why it's being ignored. But if you properly put your time, it's easy to learn. Means like there are no very rocket science behind optimization of the queries. If you do some basic things itself, you can improve your query performance very effectively. Now, why does like when this comes into play, especially when there is the application is a very customized one. So the query tuning happens, as we say, one shirt fits none. Like one shirt will not fit for all, right? Similarly, every application has its own needs. So if you try to tune the things as per your application, you can like uh, save a lot of cost and resource as per the need. Okay, now let's see how we can do that. Okay, so especially when it comes to the DB, Oracle DB. So we need to understand the architecture. Okay, so how does this Oracle DB work, and what are the different architectural parameters in that? We will be seeing that. Okay, so let me open the. So let's jump into the architecture a bit. Okay. Just a minute, I'm opening my tab. Yeah. So this is a basic architecture of an Oracle DB. So if you draw the whole, if you see the whole architecture of the Oracle DB, this is how you can represent it very simply. Okay. So this is a very high level diagram of the Oracle DB architecture, and it covers almost every component. Okay. Now, if you see this architecture of an Oracle DB, there are multiple sections to that as per the functions which it tries to handle. Okay, now for example, there is a PGA. Okay, so basically it's a private area, so global area basically we call it. So what is this PGA? Let's write PGA, and then there is some SGA. Okay, there is an SGA, PGA, and there is one there are different components to that. Okay, so we'll try to see those in one by one in little detail. Okay, what these are and how it constitutes to our like how they what are the functions of these layers and how it helps us. Okay, so let's try to see that. Yeah, so first we have this let's speak about this component called PGA. Now, see, whenever there is a query run, okay, or we can say whenever there is a client-side request to the database, for each request there is a session created, okay, and that session is called the sorry bad climate. Yeah, so there are different sessions, so there are different areas created in the PGAs. So each area we call it the private SQL area. Okay, now what is the importance of this area? So here the session level data or information is stored. For example, whatever the query is being sent, so that level of data, okay, so not the so each user will have a separate data, right? So those are stored in this private SQL area. For each user, that many number of private SQL areas will be created. Now this is the PGA. Now there is something called an SGA. Okay, and SGAs are basically, it's a shared global area, not private. Okay, so now what is shared? So this is being shared by all the users. It's not only for the one user. Okay, so now what are these sharing activities done, right? We need to understand. So let's see this one by one. What are the importance of these?
Vishnu, we can say that PGA is a private and SGA is a global one.
No, we can't. So it's basically, see, whenever you, as I said, so PGAs are basically, it's private to the user. So that's why it's called private global area. And
Mhm.
SGA is not shared between the users. That's why it's called shared global area.
Okay,
Okay.
that's why I'm
So
just using the word global for that. And the
yes,
first
yes,
one for
correct.
PG, I'm using the private one.
Correct. Yes.
Okay.
Right. So now let's try to understand the SGA components in little detail. Okay, so there are different SGA components as you can see, right? Now, first of all, there is something called uh, a library cache in the shared pool. Okay, so this is called the shared pool. So this is the shared pool which we have right here. This one is the shared pool which we have. Now, this shared pool is very important component of of the DB architecture of the Oracle DB. Now, this shared pool has some other components. Okay, one is the library cache, we call it, then the data dictionary cache, then the result cache, and some other. So, other is not that much important to us, which is a DBA level. And like which is more sort of a DBA level thing, which we don't need to learn now. But what is more important to us, okay, that is these three components: the library cache, the data dictionary cache, and the result cache. Now now let's understand how what are these components, so that it will help us in tuning the architecture. Okay, because to tune something you need to know what these do, right? So as the name suggests, I will start with the simplest one. Okay, it is the result cache, because the name itself is a little guiding us towards what it is. Okay, so what is the result cache? So result cache is nothing but, let's say I run a query. Okay, so let's say I ran some select star from let's say some employee table where salary equal to 500, something like that. Okay, I run some query like this: select star from employees where salary is equal to 500. So I'm just pulling out the data for that. So now I ran this query once. Okay, so I get a result. Okay, so let's say I got a result for that, which is some result one. Okay, so when this query is run first time, I got a result. So that result will be stored in the result cache. That R1 will be stored inside the result cache. Now when I run it second time, what will happen is, this query I already run, right? So I don't need to do all the headache of running this query and all. So because that result is already there in my result cache. So what Oracle DB will do, it will pick up that data from the result cache and print it. Getting my point? So that's the result cache. So it will store the results of the queries which are being run. Okay. Is it clear, everyone? What is the result cache? What's the functionality? Okay, I'm hoping no questions. So I will move on. So next is the data dictionary cache. Okay. So now what is this data dictionary cache? So data dictionary cache actually stores the table definitions or the table schema we can call. So let's say again you ran this query for the query which we said, right? Select star from employee table and that's all. So now this employee table is there, right? Which we are accessing. So once we have accessed that table, so what my Oracle DB will do is it will store the employee table related schema, or we can say the table related data inside the data dictionary cache. So what will happen next time when I pull the table employees table, that table, how many rows are there, how many columns are there, how many indexes are there, and those details, no, I will get all those from the data dictionary cache, the table schema details. Okay, so automatically I don't need to go further and check the database for those details because it's already there in the cache, and cache is always the fastest memory. Is my voice audible? Because it's raining little heavy here, so my voice could be okay. Yeah, thanks, Dave.
It's fine.
Okay.
Vishnu, see, what are the query you are just firing in the first time? It is not coming to the cache, right? That's why your first transaction is going to be more time compared with the second one because it's in the cache or the fastest memory. So that whenever you are anybody is going to hit the second time that particular query, it will take less time. That you are trying to say?
Correct. Yes, yes.
Okay.
Okay, sure, sure, Dev. I will explain you what is data dictionary cache. See, basically, okay, then to make it more clear, anyway, I will be going deeper into these components, but this is more sort of overview. But okay, since this question is there, let's try to understand what is a table schema first. Okay, so now what is a table schema? Basically, in database, table schema is nothing but the table related data. Okay, so table related data is, let's say you have a table. So how many rows are there? How many columns are there? And how many indexes are there? What type of table it is? What data types are being used? What's the block size? So those details. We'll go to these in detail. These terminologies. No need to worry. Like what is block size? I don't know, because we'll be seeing what is block size. But for now, you just need to know, like it's more sort of like you have a table. To access the table, to get the fetch the data, you need to know, right? Well, it's more sort of like a we can say and a summary of the table. It's called the table schema. So now that table schema is stored inside this data dictionary cache. Now which table schema? The tables which we have accessed. So let's say when if I run a query, select star from employees. So here I'm using the employees table, right? So that employees table schema will be stored inside the data dictionary cache. Now next time, whenever this employee table is being accessed by any query, that data is regarding that table schema is already there inside my data dictionary cache. I don't need to go further deep to get those details. Okay. So from here itself it will take. So it will save my time and resource. So that's what the use of a data dictionary cache means, and that's why it's called a dictionary. So dictionary means like it has the table related data. I meant not the internal data, what all is there inside the table, but how many rows, how many columns, what all indexes, and those details. Okay, so that's stored inside the data dictionary cache. We will go a bit deeper when we see the data dictionary cache in detail. But for now, it's more sort of it stores the table schema, right? Dev, is it clear? Yeah. Okay. Thanks. So now let's move on to the library cache. Okay. This is a very important. Sure. Thanks, Dev. Yeah. I always I like to keep it interactive. So any questions, any queries, you can ask me and anytime, because this course is more sort of very much interlinked course. I meant if you pass from one subject, one topic to the next, uh, it's more sort of connected. So if you miss one topic, the other topic you might feel tougher because you would have missed the past one. So you can clear the queries when that topic is being covered, so that in the next topic it will be easier for you to understand. So no need to wait till the session's end. So whenever these queries you come across, you can ask me. Okay, you can interrupt me anytime. I will go back to those things.
Yeah, Vishnu, before describing all type of dictionary part, okay, means how
Yeah,
that is, if you want going to say, describe that particular architecture whenever you are going to insert any type of query, how that
yeah,
flow is going on in between this architecture, so that it will
correct.
be easy for us to understand.
Yes, yes. So this one is more sort of an overview. So when I go deeper into this architecture, I will be showing that way only. Because first you need, because this is a demo, right? So in demo, I can't cover everything. So, but what I'm trying to do is to give you a good amount of stuff in the demo, so that you get an idea like what all being covered. When I go deeper in the real sessions, that time everything will come into picture. Because if I go in that way, I won't be able to cover some other stuff which I want to show.
Okay, Vishnu.
Yeah. So this is the library cache. Okay. So library cache is more sort of, if you have heard, for any query, okay, when you're running any query, there is an execution plan, or we can say an explain plan being generated by the Oracle. Now let's understand quickly what is this execution plan or an explain plan. Now let's say I'm running a query. Okay. So now I have a query. Let's say query one. Now this query one, let's say that query is select star from, let's say, uh, again employees, where some salary parameter is equal to some 500, something like that. I'll have a query like this. Okay. So this is my query. Now Oracle has to execute this query. Okay. So for executing that query, Oracle will have a plan. So plan means like how it has to execute the query. For example, now it has a select star statement. It has from employees and from where. So whether it will go to the employees table and then select the employees data first, and from that it will filter the salary. That is one way of doing it. Or let's say what it will do, it will pick up all the data from that, and it will, let's say, sort the data first, and then it will choose the employees where the salary is 500. So there are different ways to do the same query, right? With different ways to execute the same query, how the Oracle will execute it. So that method of how the execution is being happening is called the execution plan. And Oracle will always choose the execution plan for which the cost is very low. So there is something called a cost parameter, as I said, in the Oracle DB or any DBs when we speak. So this cost basically is a metric we can call, which covers most of the resource utilizations like the CPU, the IO operations, and all those. Okay, we'll go to that in deeper when we go ahead. So this cost it will try to reduce. So it will choose a execution plan for which the cost is very less. Okay, and that execution plan it will use for that query uh, later on, like whenever that query comes into picture. Now where does Oracle DB store this execution plan? Whichever execution plan it has used to execute a query, where does it store it for the future use, right? Like you had a query, now you have executed, you have execution plan for that. So whenever that query will come next time, you need to use it for that query again, right? So that execution plan. So where do you store it? So that is stored inside the library cache. So library cache stores the execution plan of a query. Now all this storage, okay, now you will have a question, okay, in this execution plan is getting stored, in this table schema is getting stored, in this result is getting stored. Now how does this get stored, like in what form, right? So these all these things are getting stored with something called a id. Okay, so let's say if I have a execution plan being stored in the library cache, each will have a specific id, and that id will have a specific execution plan already mapped. So if whenever Oracle finds, okay, that query is being run again, okay, so it will look for that id and run the execution plan whichever was used for that id. That's how it happens. Now we will see it in detail as we move for now, but I guess now you all are aware, like, what is this shared pool area and what does it do. Basically it will store all those we can say the recurring sort of data which are being processed because these are little heavier activities. That's why we are storing it in cache. Now why this storing it in cache is happening is because now there are different components, right? There is pga, right? There is sga, there is a disk. So now whenever something is not there in the cache, any of the cache, it is always taken from the disk. So this is the disk, right? And whenever there is some operation happening from the disk, it is costly. Costly means it is slower. Okay. And to avoid those costly operations, that disk operations, what Oracle does is it stores in the cache. Okay, so now let's say if I have I'm running a query for the first time, I doesn't have the execution plan. So that query data, it will pick from the disk. It will generate an execution plan. It will execute the query. Then once the query is being executed, it will send the executed data to the user back. Also at the same time, it will store the data of those query. For example, the result, the table schema, the execution plan inside the cache. So when the second time, so first time I executed, it will go to the disk. Second time, when the same query is executed, it will not go to the disk. It will not go to the disk. It will go to the cache, and which will reduce our time a lot, right? Because we are not using the disk, because the disk operations are very costly. Now, can anyone guess? Like, we have stored the execution plan, we have stored the table schema, we have stored the result, but there is something else which we haven't stored. Can anyone guess what it is? Which we can use again and again. What could it be?
Vishnu, I'm unable to say that one, but one question is coming in my mind before giving that answer.
Okay,
Suppose
okay.
I'm just making an execution with every time a new user. Okay, in that case, if
Mhm.
any user is going to fire, then cache is not going to work for that particular user, right?
Correct. Yes. So basically, there is something called hard parse and soft parse. Okay. Hard parse will happen every first time. So any new query, first time it is executed, it's a hard parse. Then soft parse is basically whenever the cache activity happens. Okay, so whenever that query is being executed second time or third time, it will always be soft parse until the data doesn't change. If the data changes, again the hard parse will come into picture. We will go to these in deeper, but yeah, since you asked that question, yeah. So every time, that's why whenever you run a query or some application performance testing as such, you would have seen, like, whenever you're doing it first time, that data should be inserted, or the data DML operation which you're doing, okay, it should be for the first time. If you do that, you will see the variation in time which it is taking. First time, if it is like 1 second, generally, okay, the cache will reduce 70% of that time. For example, if it is 1 second when you do it for the first time, second time it will be around 300 milliseconds. Surely it will reduce that time that much, the cache. Okay, so that's why the first insertion will be always little heavier, because it happens through the disk. Getting my point? Any queries in that again?
No, it's fine.
Yeah. Okay. So any guess what could be the thing which we can store further from rather than accessing the disk? Anyways, we have stored the execution plan, we have stored the table schema, we have stored the result. What else can
Gaurav,
we store?
I have one more question.
Yeah, Gaurav. Yeah.
Yeah, the question related to if suppose there are 10 records that we are pulling from the employee table, but
Yeah.
what happens is that we have run the query and we have pulled the data from the disk first time, and
Yeah.
it comes 10 records. But again, 10 more records got inserted after that, and then
Hmm.
when we run the second query, then how from where the data will be pulled? Is it from the cache or is it from the disk?
Great question. So that's what I was asking this question. Any guess? So there you came, right? That's the data. Now here, are we storing the data anywhere? Here we have the execution plan. Here we have the table schema. Here we have the result. But we are nowhere storing the data, right? The data, the real data. Like for example, salaries of we have some 10 salaries like Dev, Ram, then Arun. Dev has 500 salary. Arun has 100 salary. Or as like that. That numbers, that data is not stored anywhere. So where is that data stored? That data is stored inside the buffer cache. Okay. Now this buffer cache stores those single column datas. Okay, not only the row data. So the column level data is stored inside the buffer cache. So whenever that query will be executed again, so that data it will get from the buffer cache. Now the question comes. So what if that data changes? So this activity constantly happens between the disk and the buffer cache. Now what this buffer cache will do is whenever any DML operation is happening, DML means like some insertion, deletion, and all those. Whenever that happens, every time this buffer cache will be flushed, and new data will be updated. Getting my point, Gaurav?
Yes, yes. Okay, I got it. Yes. So it
Yes,
will
yes.
make use of the buffer cache. Okay.
Correct. Yes. So that's how the buffer cache comes into picture. So buffer cache is a bigger. If you see the buffer cache size, okay, it will be bigger than all other cache. The Java pool, Stream pool, the shared pool, all those, because the buffer cache stores a lot of data compared to the other cache. Okay, so that's why the size, like if you let's say the total SGA size is 3 GB, out of that buffer cache size itself could be 2 GB. Okay, which is controllable. It will change with respect to the configuration which we are setting and all. There are some parameters which you can use to set those values, like how much the memory should be and all. We will see that. But what I'm saying is it's always higher compared to the other cache because it stores a lot of data in that. Now, but again, it's a cache because it's far more faster compared to the data stored in the disk. Now if the disk data is like let's say 100, okay, what is stored inside the buffer cache is just 5 or maybe even just 1. So it's almost 1 is to 100, right? So the data stored and the time required to fetch and all will also be 1 is to 100. It will reduce 100 times. So that cache is very much important in that sense. Now obviously whenever the data is not there in the buffer cache, you are executing something very new. Obviously the data will be fetched from the disk. Now this question comes, whenever the data is fetched from the disk, okay, will it go directly to the PGA? So let's say I'm fetching a data from the disk. Okay, so let's understand the flow. Okay, whether it will go directly to the PGA or whether it will pass through the buffer cache and go to PGA. This is case 1 and case 2. Any guess?
Maybe from buffer cache to PGA.
Great, Arun. Yes, because so whenever a new data is being accessed from the disk, what my buffer cache will do is it will flush the very older data. Okay, and there is an algorithm for doing that, which data should be flushed, and it will insert this new data first into the buffer cache, and then it will go to the PG. So next time, whenever that query will be executed, I will have that data inside the buffer cache automatically. So that's how the flow happens. Now there are some statements which doesn't need storage. Okay, like there are some exceptional statements, maybe some get statements where we are reading the table, and that that requires some generic statements like it's always that. Okay, in that cases only what will happen is it will directly read from the disk, only the read. Okay, the writing will never happen. Okay, only reading. Whenever the operation is only reading, it can directly go to the private area, but whenever there is writing also, it will always go through the buffer cache only. I hope it's clear. Like what is this buffer? I meant the disk and buffer cache relation. Okay, because that flow is very important. We will see this flow in little detail as we go ahead. Because, for example, even the library cache has further components inside it. We'll be going it in deeper. Okay, so that time things will be more clear what it is. So that's about the buffer cache. Any question regarding buffer cache?
Vishnu, which one is there any relationship between buffer cache and cache, or which one is the fastest now?
Arun, can you little elaborate the question? I didn't get the question.
See, now there are cache and buffer cache is there, right?
Yeah.
In that case, if you want to, as you said previously, cache is the fastest one. And
Okay.
In that case, can you compare with buffer cache? Which one is the fastest one to get the result?
Actually, see, I'm just trying to understand your question. So basically, what you're saying is, first time you ran the query, because even your sound was little feeble. I didn't
Yeah,
get that.
it's fine now.
Yeah, it's fine now. It's little clear.
Okay.
Yeah.
Mm-hmm. As you said that cache is the fastest memory. Okay.
Correct.
Then what will be the buffer cache?
Okay. Okay. Good. Okay. Yeah.
You got
So
it now, question, right? Yeah.
yes. Yeah, got it. So basically, you see it in such a way. This total thing, right? This total, the PGA and SGA, is more sort of like a cache. Okay, so this is more like a cache. Now this total is a cache. Inside that there is something called a buffer cache. Now what I meant to say is this thing and this thing is different. This is the disk, right? This thing total is a disk. It is not the cache, but this total thing, the PGA and SGA, constitute the cache. Okay, now inside that cache there are different types of cache: the library cache, the dictionary cache, the result cache, and different cache. In that, the buffer cache is the cache which will store the data. Data means the column level data. Whatever the numbers and all, everything will be stored in the buffer cache. Is that clear now? So this is also a cache. Like this is also a cache. There's not like everything is cache only, but different types of cache. Is it clear, Arun?
Yeah. Suppose Vishnu, I'm just writing a function web underscore clear underscore cache. Okay.
Yeah.
In that case, it is not going to clear the server cache, right?
No. So this
It
is
will clear the cache only the browser part only.
correct. Yes. Obviously.
Okay.
Now this cache, if you want to clear it, there is something called the Oracle level memory management, which you need to do. Okay, so every time you can clear the cache, you can flush the cache, but for that you need to go into the DB and run some queries to flush that. Okay, but there is automatic memory management also. There is something called automatic memory management, so that we will see as we progress. So basically, whenever let's say library cache is full, like let's say library cache is 50 MB. Okay, now it's almost like 48 MB. Now it needs to clear the data, right? Because it needs to add new data to it. So how will it do that? So there is something called automatic memory management feature of Oracle, which will do that. There's an algorithm which is running. Specifically, we can set the attributes, different attributes. We will see what are those attributes. Using that, you can command Oracle. Okay, whenever it hits 48, flush the data and with a specific signature. For example, flush the data which is very old and which is never used. So those data you delete it. So those things, such things we can command Oracle and it will maintain the memory. And it is a very important bottleneck. Okay, so when it comes to performance, we always need to know how much memory spare we have in these cache, because what happens generally, like let's say if my library cache is 50 MB. Okay, now my library cache is hitting 48 MB. obviously I will see lot of performance degradations due to that. Now, so what I need to do, what's the fix I need to do? Either I can flush the library cache, so that I can reduce that, I can increase the size of that, and once I optimize the query, I can hold more data in that library cache. That's the first solution. Second solution, what could be the solution? I need to increase the size of the cache. Then only I can improve the performance, which is the very I meant last solution, because increasing the cache is a costly affair. You can't directly increase without any justification. Okay, so that's the last option. But yeah, these are the bottlenecks which you see. The cache size, okay, is very important. So how do you get the cache size? So those from the reports you can come to know, okay, which is like getting full, and if the buffer cache fragmentation issues are there. Okay, you would have heard disk fragmentation. Similar to disk fragmentation, there are the buffer cache issues also. Okay, so how to fix those? We will see that in later sessions.
Vishnu, I
Is
have
it
one more thing. I have,
yeah,
this is Gaurav. Yeah, I have one more thing. So when does the interaction happen between the disk and the database buffer? Is it in case of insertion, deletion, or manipulation or updation? Is it in these cases only?
yes, correct. No, in reading it will not happen. In reading, generally, if the data which needs to be read is a very huge, it will directly take from the disk. But if the
Okay.
data what I need to read is smaller, which is already available in the cache, it will pick from the cache.
Okay.
Vishnu,
Okay.
we can say that that is a DML statement only, right? Insert and delete.
Correct. Yes. So
Yeah.
basically DML, like whenever the data is updated, okay, we can say in the disk, or like you delete something, you insert something, you merge something, okay, during those things. Yeah.
And what are the things you just described, like your automatic memory management, like your GC, how it is happening in Java? The same thing it is going to happen here.
Correct. Correct. Yes. It's more sort of that you'd have heard this minor GC, major GC, and all, which happens in
Right.
our JVMs. Yes. So similar to that only here also, Oracle has its own automatic memory management feature. Okay, but that will sometimes lead to bottlenecks, which we need to analyze, and that especially that bottlenecks will happen due to the sessions, some active sessions which are not being flushed, or some data, corrupt data, which is not being flushed, and those we will be seeing like how we do that in the further sessions. Yeah. Okay, so any other question? Then we will move to the redo log. Like this is the last component which we need to see, right? Which is important. The Java pool, again, Java pool is basically, it will store some Java level objects and all, which is not that much important to us as a performance engineer. We don't tune that much. Even the stream pool is for some video streaming and all those things, types of stuffs where the streaming happens. So those are related. So again, this is also not under our scope. Even the large pool. Okay. So majorly a performance engineer will be very much interested in the shared pool, the PGA, the buffer cache, and the redo log buffer. These are the four important components which a performance engineer will look for optimization. Okay.
Vishnu,
Now let's
one question. What is this redo log buffer? Sorry, I think I missed it. Is
no,
it
I
the
am
repeat request to get saved?
yeah, no, I'm coming to that actually what it is. I haven't come to that. Next is that. Yeah. So now let's try to understand what is redo log. Okay. So redo log, from the name itself, any guess which comes into your mind with the name. Okay, the redo log. What do you think? What could be the redo log? Like, what could be the use of this redo log buffer? Any guesses? Wrong answer is also not an issue. We are like it makes
We
the class.
heard about undo and redo. Okay, the means as per my understanding, what are the execution you have done that comes under here itself?
Yeah, so basically now what are these redo log files? Okay, so Now let's say I did some operation, okay, like I did some delete or I did some DML operation, okay. Now when I run a DML operation, like some insert, delete or something, how is it, like what do you think is the difference between undo and redo? Like generally when we do some redo and undo, what's the difference? What is happening in undo and what is happening in redo? Okay, so I will come to it. No worries. So basically, see, whenever you are doing some update, like let's say you did some insert, update, or delete, or let's say you create something, or you altered some table, you dropped some table. Okay, that time, every time one redo log entry will be made by the Oracle. Okay, now this redo log entry, what it does is, so now let's say when I do that operation, okay, some sudden failure happened. Sudden failure means some disaster level issues happened, okay, or like let's say my server crashed, or let's say I need to do some I need to whatever I did was wrong, and I need to quickly recover those things and all. Okay, so these redo logs will be used for that recovery operations. Okay, the quick recovery, like see, this is not related to rollback, that you need to remember. Rollback is a totally different thing. Rollback will not happen through redo log, but redo log buffer is more sort of a small buffer, okay, or small data logs which are stored for a smaller operations, like quick. It's not like it's not stored for long durations, okay. It is stored for a shorter duration. So whenever you do make an operation, if you want to recover the data, okay, due to the loss or something, that can be recovered using the redo log. Now this redo log again has one buffer and one disk, so our data will be written in the disk and the redo log buffer both. So now the whenever the redo have recovery happens from the disk, it is costly. Okay, we will see when that happens, okay, when it comes from the disk and when it comes from the buffer, that we will see. So whenever it comes from the disk, it is a costly affair. Okay, we need to avoid that. Now the when it comes from the redo log buffer, it is faster, okay, because it's again from the cache, and it's faster. Now again, like is it clear what is a redo log, everyone? It's more sort of a recovery. So let's say I inserted some data, right? When I'm inserting the data, whatever the data I'm getting inserted, it's more sort of a copy it will create and keep it. Okay, so until my operation is totally successful, that copy will be there. Okay, and once my operations are successful, again that copy will be still there. Okay, but so later on, when if I need to recover something and all, I can use that data to recover. But again, this has a specific amount of time frame, or we can say a specific amount of memory which it can store. So whenever that memory is full, that older ones will be deleted automatically. Okay, so that's taken care. Is it clear about redo log? Anyone, any doubt? It's basically for not losing the data. Okay, so redo log is basically for you don't lose any data, to ensure that. We'll be going in deep what it is, because there are multiple components to redo log. For example, redo log buffer has a log writer process, then redo log files, then there is a server process. We will see that how it happens. But for now, is it clear like what is a redo log, everyone? It's more sort of the data used for the recovery. In simple words, if you see, say.
Means if something is going to be crashed, then how we are going to recover those data? That's why we are using redo log, we can
Yes,
say.
correct. Automatically, you can recover the data. Yeah.
Okay. Okay.
Yeah. Okay, yeah, so that's the last important component. Now we will go into these components one by one deeper. Like for example, we have the shared pool, right? In the shared pool, for example, if you see the PGA, for example, the private global area, in that we have session area, we have the private SQL area. In that private SQL area, we have persistent area, runtime area, cursors area. Okay. Now in the SQL work area, SQL work area. Again, there are different areas like sort area, hash join area. So these are like components inside PGA. Okay. Now, if you speak about SGA, the data dictionary cache, obviously we saw. Now we will see little bit more on the buffer cache. Okay, so in buffer cache we have the database writer process, disk, and what are like how the buffer cache fetches the data. Those things we will see. Then we have something called an undo data, right? Like if you need to do, you need to undo something. Okay, so there is something called an undo data. So how generally that happens? Okay, how that undo data is stored. Then how generally this DML operations are processed and all those we will see as we progress ahead. Okay, so for today I'm not continuing further. I'm stopping here because I won't be able to complete it if I continue here. So let's continue it tomorrow. I meant the next session. I guess it's when it is it tomorrow? Yeah, tomorrow we have the next session. Yeah, so tomorrow let's continue with this. So tomorrow mainly we will be seeing some hands-on example. Okay, because it's more sort of like you get a feel like how we can tune the queries and how we really save the cost. Okay, so that we will see tomorrow, and more on this architecture also we will try to understand. And yeah, so that we can continue tomorrow. If no more questions, we can close the session for today.
One thing I want to share with you. Once I have done one type of test, at the time of execution, I was just up to 30 minutes. I was not getting any type of error. Okay, and after
Yeah.
30 minutes, I was just getting a lots of error.
Okay.
Then I'm just moving the same thing twice. Let's see what's wrong, what went wrong to be there. Then
Okay.
the same test I have done after some time, and I'm also getting that after half an hour also getting the same type of error. Then
Okay.
I've just connected with the environment team, and from there I got to know about it, that ORH 01000. That is the
Okay.
main issue, and
Okay.
it was the meaning that maximum open cursors exceeded. Could you tell me something about that? What exactly it means?
So basically, what did they say? What was the error you saw?
ORH 01000 maximum open cursors exceeded.
Yeah. Actually, see what happens. No, there is something called cursor sharing. Okay, if you, we will see that there's like there is some feature called cursor sharing. Now, what is this cursor sharing? For that, you need to understand what is a cursor first. Okay, it's a SQL level thing. We will see, but now we do. It's little. I can't cover that now. It's little deeper, but yeah, I will say just in an overview. Now, for example, if you run a query, like let's say something you are running, and there is something called a cursors, okay, which is already set inside the database architecture. Now you can alter that cursors using the command alter system set. I will just give you that command. If you are a DBA, you can do that generally. Okay, just a minute. So there is something called alter system set open cursors. Okay, I will write it down for you. Basically, this is the parameter which is creating the issues of open cursors is equal to some value 3000 whatever. So whenever this open cursors or the cursors which we have kept the max limit, okay, is exceeded, what happens is it will not create the cursors further. Okay, and when that happens, new records or new DML operations won't happen, and that's why you're getting the issues. So basically, that's the main issue. There is a volume which you are inserting, and the attributes or the parameters which you have set in the DB are not matching. So only thing what you can do is either you need to increase the cursor limit, or the other way to do that is to insert it like a queue in batches. Like for example, if you want to insert 3000, so if your cursor is 500, anyways you can't go with 3000. So what you need to do, you need to batch. So you need to divide it into 6 batches in the queue. So you will need an extra layer, extra component called queue. Getting my point?
Yeah.
Yeah. Cursor sharing, we will see. There is a topic on cursor sharing, so you will clearly understand what is this cursor sharing. But it's a deeper topic. It's a little advanced topic, I will say. So we'll be seeing it at the end, around the end of the course. What is cursor sharing?
Okay.
Or even you can read it that it is nothing but cursor sharing. If you want to jump into that, yeah. If you read it more, you will get more idea about that.
Yeah, that I was just getting at the in the year of maybe 10 or 11, something like that, and not 10, 11, maybe 13 or 14 in between that. And
Okay.
Vishnu, Giri says, just asking some question on your chart.
Oh, did he ask? Okay, let me check. Yeah. AWR, we have one session fully on AWR, like because it's very important. And AWR is a very huge report, the workload repository. Okay, but as a performance engineer, many people don't know that out of the 100 data what we have inside that, let's say I have 100 data in that, only 10 data is useful to me as a performance engineer. So we will see what are those 10 data. Okay, and how that will help us in tuning the database. Yes, we will be going through those. We have a one whole session on AWR. It's a very important session because AWR is a starting point of, I will say, database performance engineering. You need to pull out the report, AWR report. You need to analyze. Yes, we already have it. And if time permits, again, AWR is obviously there. There's something called ADDM report also. Okay, so but that I don't know whether if I will have enough time to do that. If I have, I will add some thing on that also. It's basically a diagnostics report, okay, which we have ADDM. Let's see if time. I'm not committing that one, but AWR is surely there. Okay. Yeah. Any other question? Anyone?
One last question, Vishnu. Apart from Oracle DB, are you going to cover any other part of the DB performance or tuning part?
The Oracle DB is the main DB which I'll be focusing on, because with the time we have, I don't want to falsely commit. Okay, whether I will be covering other DBs because this itself. But yeah, one thing is there. The core structure is in such a way that, for example, only this architecture will. That also most of the DBs have similar architecture. If you compare SQL DBs, okay, not the NoSQL DBs, but the SQL DBs. Now, the only thing what will change in this course, which won't be much useful for you if the DB is different, is the architecture, basically the PGA, SGA, and all those stuff. But the execution plan analysis, the AWR report, those things and all will be common in most of the DBs, and which is what people generally use to optimize. The architecture level optimizations rarely happen. That's the reality. Architecture means like increasing the cache size or reducing the cache size and all. It's very the last option, okay, you can say. So always the starting option is tuning the query only, SQL tuning, okay, which we will be seeing. And SQL tuning is common for all the DBs generally, okay. The methods which we use will be applicable to most of the DBs. But yeah, let me see if time permits. I will go through the SQL architecture also. But if I complete all the other critical or priority things which a performance engineer requires, okay, after I complete that, if the time permits, I will even cover the SQL DB architecture, which is basically constitutes 80% of our DB. If you cover Oracle and SQL, MySQL DBs, 80% of the DBs now applications which are there are on this. If you see, the other 20% are only the other, like if even you consider NoSQL DBs and all in the market.
So you're going to consider both Oracle and MySQL DB, right?
Yeah, but MySQL is an optional one as per my time constraints. If
Okay,
I
because
can,
actually many of the organizations also use MySQL DB. That is what I was just trying to check. Because
correct.
my current organization, few of the projects, they don't even have the Oracle. They are completely based on MySQL. Just wanted to
Yeah,
understand that. How will that be different? Like MySQL tuning, the tools and things will be very different, right? Because Oracle, many of the projects they don't take it because of the kind of costing overhead they need to take it, right?
Yeah. So basically, the MySQL DB you'd have heard there is something called utility layer and all, but the things are pretty much similar. Okay, the PGA, the utility layer is nothing but the PGA, similar to PGA. So there is lot of what I'm saying is there is lot of comparison. Okay, which is common. So if you learn this, it is very easy to learn that. I meant 80% of the things you will cover with this. Now only the 20% things what you will need to cover is the flow. Like the MySQL DB has a different flow in the architecture. Oracle DB will have a different flow. So only that if you try to understand, the other 80% of the tuning, what you do is similar.
Okay, and how about the tools? Because most of the cases, Oracle, we see that people takes AWS report where they are able to fetch most of the details or the issues and they'll be able to diagnose, right? But how it happens in MySQL?
Yeah, so MySQL, the reporting thing is little different compared to Oracle, because Oracle has something called Oracle monitoring tool, right? Right, the Oracle Enterprise monitoring. If you would have used Oracle DB, you know that. But in MySQL, it's there is no such tool which it provides in MySQL. But there are some standard SQL commands like the DBMS explan and all those. Okay, but in MySQL, there is something called MySQL Server Status Report. If you have heard about it, MySQL Server Status Report.
No, not
It-
much. I am not so much versatile with the DB part, so but I
okay.
see that in
No issue.
the current trend.
Yeah. So there is something called MySQL Server Status Report, which is very much similar to AWR, though not that much detailed like AWR. But there is something called MySQL Server Status Report, which also you can pull using some simple commands like the SQL commands.
Okay, and is that free or it is paid again?
It's free. It's free. MySQL, everything is free.
Okay, thank you.
Yeah. Any other question? Now, even the MySQL monitoring, no, there are a lot of free tools available, the plugins and all, which you can easily install and analyze. But see, again, it's more sort
Can you
of
name a
now.
few of those?
There's something called MySQL. There is, if you go to this MySQL Workbench manual, no,
Mm-hmm.
if there you can see this. I guess you would have seen this MySQL dashboard, right? Where you get this MySQL status, network status,
Yes.
the InnoDB status and all, right?
Yeah. Yeah.
Yeah. So that is similar to the Oracle Enterprise SQL Monitor, right? It's similar. I won't say very much accurate like Oracle because the paid one, we can't compare both. Okay, but it's there. Okay. So there are comparisons always, but ultimately, like let's say from the MySQL Server Status Report, you got the active sessions count. Now, how can I reduce the active sessions count by? So that is similar in both the cases. Getting my point? So where to look, what to look is similar, but how to look is different. I meant the report, what you need is different, but in that report, what all things you need to look is same in both the cases for tuning. Getting my point?
Yeah.
Yeah, so that's what I said. The comparison is similar. Obviously, for free things, there are more challenges because it's free. So MySQL, so there are like you need to run some commands which are, but the community is also very huge for MySQL. Okay, so a lot of commands and other things what you need, you will get automatically from the community. But ultimately, analysis you need to know how you analyze. So that will be similar for Oracle and MySQL. But NoSQL, I will not compare. Okay, with the analysis will also differ for NoSQL and SQL. Okay.
How about the PostgreSQL? PostgreSQL is also a kind of a relational database only, right? So that tuning, how does that differ?
Similar. Nothing much of a different. It's similar, like the analysis and everything. Things will be similar in PostgreSQL.
All right. Yeah. Thanks.
Yeah.
Thanks, Vish.
Okay, then if no more questions, let's stop the session for today and let's
Tomorrow at
meet
what time? Same time?
same time.
Okay.
Sessions will be on only thing is sometimes it will be if time permits, I can, if everyone agrees, I can take on Saturdays, maybe two sometime longer sessions I take on Saturday, so that I can cover some good amount of like I get a continuity. Okay, so there are some things which needs a continuity, so Saturdays. But yeah, again it's based on the audience. If no one is interested for Saturdays, I don't take it generally. But if some people say okay, Saturdays are fine for us, then I sometimes pick some Saturdays. Otherwise, it's general daily, same time as usual. And the sessions, I guess, generally we will have around 20 hours. That's what we plan. But based on the interactions and all, it can fluctuate between 22, 23 hours as per the course, as per the interaction mainly, like how the audience is interacting. So in that sense. Okay. Then I will not pick up more, take more of your time. Anamika, any queries you have? Okay, I guess she's on mute. Dev, any queries?
First, I'm good. Thank you.
Yeah. Arun, any queries?
No, it's fine, Vishnu. Thank you so much for your time.
Yeah, thank you. Girish, any queries?
No, Vishnu.
Okay, okay. Yeah, thank you, Girish. Gaurav?
No, nothing else, Vishnu. Thank you.
Yeah. Raj? Okay. Yeah, then yeah, thank you all. Let's meet tomorrow. Have a good day.
Thanks, Vishnu. Bye bye.
Yeah, bye.